Hello React Native developers, what is going on? Welcome to Can It Be Done in React Native? This week we look at an award-winning to-do app. Hello guys, I hope you're well. William here, recording from beautiful Zurich, Switzerland. I'm just back from the app.js conference in Krakow, Poland. I had absolutely a blast. It was amazing to finally meet some of the people from the React Native community, and I found the talks to be extremely interesting. I hope they will be available on YouTube soon. I'll definitely make sure to link them from my channel once they are available. I think they covered some really interesting topics, and I must say the organizers have done an incredible job with this conference. It was the first edition. I really hope there will be new editions in the future, and I'm also very happy that I got to visit Krakow. It's absolutely a wonderful city, and I had a really good time also visiting the city. And I also had the privilege to present the Can It Be Done in React Native series to the audience. And today I would like us to take a look at an example that I presented on stage last week, which is the Clear To-Do app. So yet another to-do app, but not any to-do app, because this one is an award-winning to-do app. It received many awards for its great design. I'm actually quite blown away by the creativity of some of the user interactions within the app. And today we are looking at the gesture to create a new item, which is a pinch gesture. So here I'm pitching to create a new item. So you see, when I start pinching, there is this pincher pack to create new item in 3 dimensions. The text folds nicely. We have some shadow effect to the item that is about to be created, to add some realism. So pretty cool effect. And you see, this app contains, I think, tons of great gestures that we could implement together using React Native Gesture Handler and Reanimated. Great use case. And today we're going to look at this one, create a new item. So how would we do this in React Native? So obviously we would use the gesture, is a pinch gesture. So we were going to use a pinch gesture handler from Reanimated. And so that's the gesture. And then when we start pinching, we need to know, so some of the items translate to the top, some of the items translate to the bottom. So when we start the gesture, we're going to store the value of the focal point in a variable, and we know that any items which are positioned above this value need to translate to the top. Any items that are positioned below this value needs to translate to the bottom. The way we, for the item, for instance, to be at this position, what should be the relative scale value depends on us. We can play with different values to see how sensitive we want the gesture to be. And we also need to decide the color of the created item. And so for this, we're going to use Reanimated as well. Reanimated provides capabilities to interpolate colors. So here we know at which index the item needs to be created. So we can simply interpolate the color from there. And then the last part is this 3D fold animation. We did a video about that topic last week where we folded a playing card So if you've seen this video already, you know how this effect can be done. If not, let me just open my slides. So this is my slides from the conference. This is exactly the same technique that we employed in last week's video with the folding card. So we overlay two identical views on top of each other, and we rotate them on the x-axis, one from 0 to minus 80 degrees, one from 0 to 80 degrees. This is going to give us a nice folding effect where you see the text folding in the middle, for instance, which is pretty cool. And finally, we need to add some z translation, which we can calculate using some simple trigonometry. And we can finally convert this translate z transformation into a scale transformation. Again, same technique that we used in last week's video. I will link to it in the video description. So if you want to find out more about this particular 3D transformation, please check out last week's video. So I think that's pretty much it. We know the gestures. We know what kind of translations we need to apply to the items on the list. We know that we need to interpolate the color of the item, and we know we need to apply some 3D transformation that we've already explored the technique to build such transformation. So guys, what do you think? Can it be done in React Native? Let's have a look. And before we get started, two things. First, React Native elements. If you have a new React project coming up, I recommend you check it out. React Elements is a premium React Native starter kit. It does every 80% of what you need when starting a new React Native project, from static analysis, boilerplate navigation, and lots of beautiful UI components which are fully functional. So if you have a new project coming up, I recommend you check it out. You can try it on Android using the Expo client or by downloading the APK, or on iOS using TestFlight. So that's React Native Elements, link in the video description. And if you like these videos, don't forget to subscribe and like, but as well, you can buy me a coffee and I will give you access to exclusive content before it's released to the public, and access to the GitHub repository where I tinker to all these examples for the show. So, all right, guys, let's get started. So here I have a very simple boilerplate project, created it using Expo init. I have a list of tasks, list component. It has a header and the list of tasks. Background color is interpolated using color interpolate. And yeah, that's pretty much it. Link of the boilerplate is available in the video description in case you want to follow along with this example. So what are the tasks we need to do? First, we need to add the pinch gesture handler from React Native gesture handler and set up the animation values properly. Then we need to actually do the translation of the items that need to translate to the top and the items that need to translate to the bottom. Then we need to interpolate the background color of the newly created task using reanimated. And finally, we can do the 3D animation, which we know how to do based on last week's video. So let's get started with step 1, creating the gesture handler. So we import gesture handler from Expo. And we're going to use the pinch gesture handler. So I can put it here. And as a rule, any gesture handler needs to have animated as its first children. Animated, which we're gonna get from reanimated, which we get from the danger zone of Expo. So and now we need to set up the proper animation values. So let me check the pinch gesture handler. So we need the scale, focal Y, and the state of the gesture. So it's called onGesture event and onHandler state gesture. So up. And we use an reanimated event. So I'm gonna take this syntax here. Use native driver we don't need since we use reanimated. So I have a couple of values here. So I need to import event and value from animated. So we have scale, and I'm gonna prefix it with raw scale. We have focal Y, which I'm gonna also prefix with raw, so it's called raw focal Y and state. So let me create these values quickly. I'm prefixing the values with raw because we're going to compute the actual scale and focal Y value ourselves. So, and I can also create scale. And we need also the state variable. That looks good. So now we can actually calculate the scale and focal Y value based on the state of the gesture. So I'm going to create, I guess I can put it anywhere, doesn't matter. So animated code. So we have two conditions. One, when the gesture starts, we store the raw focal Y into focal Y, because this is what we're going to use to drive the translation, and it doesn't need to change over time. And when we end the gesture, we want the item to snap back to the original position. So this is what we're going to use for the scale value when the gesture ends. If the gesture ends, we snap back. If not, scale equals whatever is the scale given by is equals raw scale. So whatever is the scale value given by the gesture. So we have one condition, which is when the state is equal at state began, state which I can import from gesture handler. And here I can set the default state to undetermined. So then we can set focal Y to raw focal Y. So I need to import condition set equal. And the second condition is when state equals state end, we set scale to a run spring function. So we need a clock. The original value is raw scale and the destination is 0. And if the state is not state end, we give the raw scale value. No, sorry. the condition should be in set. Up, so we set scale to either the run spring function or row scale, and we need block as well, and we're gonna debug these values to see if they work before we move to the next step. So here I have okay. So let's have a look. So for scale 0, focal y 0, we scale increase, focal y doesn't move, and it bounces back to 0. Perfect. So step 1 done. Now we need to do step 2, which is translating the items that need to translate to the top, and the one that need to translate to the bottom. And so we need to calculate the index of this newly creating item, which is going to be focal y divided by the task 8. But since we use reanimated, we need to use the divide function because focal y is an animated value. And yeah, that looks good. We can also run the value as an integer to have the exact index value. So now we can create a is on top variable. So it's a condition. The index, so the key needs to be less than the index. So less than, key is less than index. And now we need to translate. So translate x is, we're going to multiply what we call the scale factor by, so if we are on top, we translate by -1. If we multiply by -1 or 1, and scale factor is a value we can set up according to how sensitive we want the gesture to be. For instance, here I can multiply scale by task 8 divided by 4. So when the pinch scale value is 1, we will have translated by task 8 divided by 4. We, of course, can use different values depending. So we have translate x, which we can use here. So transform it needs to be an animated view, of course. Okay. Yeah, that's not so it's a translate, yeah, y instead of x, but still let me see if what I can tell you already is the item translate at the right place. You cannot see my finger on the screen, but it looks actually pretty good. So I'm gonna use translate y here instead. Yes, perfect. And what you cannot see here is that actually it looks very precise. It feels very precise. All right. So that's step 2. Now step 3, we're going to create the newly created item, which is using the 3D animation that we described earlier. So let's create a new task component. Oops. And we need the, let me create, okay, a style sheet. So we are gonna need to position it exactly at the focal Y. So we're gonna use position absolute, top 0, left 0, right 0, and 8 is the task 8. Okay. And we actually need, so let me import animated here again. So we're going to need here to apply a translate Y value, which is based on the focal point. So I'm going to do transform, or should I just maybe, that's okay. Transform, translate Y should be an array. This should be an animated view. It looks good, and so we're going to pass this value as a property. And we know that we need to overlay two identical views on top of each other. So I'm going to call it new task part. And we need to, so one, again, applying the same technique than last week, one needs to rotate from 0 to 90 degrees and the other to 0 minus 90 degrees. So we use is on top property to find out in which direction we need to translate. And we're going to need also the scale. Oops. The scale component. And we're going to need the scale property as well as the task. So the string that is displayed in the component. So we have task, which is a string, scale, which is a value, and I need to create this component. So again, we have task and scale. So we need to import animated again. So we're going to use an animated view, which we're going to use to do the 3D transformation, and then the actual rendering is a task component. We can give it the task as parameter, which we get from the props. Perfect. And here I need to give a scale as parameter and task pinch to create a new task. Let's have a look. Seems to complain, but oh, we need also to translate Y to find out the position of the task, which is multiply index by the task 8. Let's have a look. Okay. So let's first maybe, yeah, I forgot to add some background color, which we're gonna use in the later step using reanimated to compute. Okay, so it looks, first of all, I need to use an absolute position fill on these views. Should I do it here? Okay, much better. And now I just need to subtract half of the 8 of the task for the translation. So let me do that. So we subtract task 8 divided by 2. So that looks good. Now let's do the 3D transformation. So we know there is 3 transform, perspective, rotate X, and translate Z, which we convert into a scale transformation. So first, perspective. So first the perspective, maybe, I don't know, here we can put any values. Then we need to do rotate X. So we're gonna have, we're gonna interpolate on the scale value. So we have rotate X, interpolate, on scale. So we go from, let's say, 0 to 2, output range. So at 0, if we're on top, we go to minus 80 degrees or 80 degrees. When we're at 2, the rotation is 0, and we need to extrapolate clamp. Is on top, we get from the props. Interpolate and extrapolate from animated. So let's have a look. Okay, so this looks super strange because we forgot to concat the unit. So we need to add degrees here. Much better, but now if you look at the edges of the task, you see you don't see really a 3D effect, and it's because we are missing the translate Z transformation. So, which, if we go back to our slides here, is this formula which we computed last week. So we can create translate Z is multiply of minus H, which is minus task 8 divided by 2, by sinus of absolute value of rotate X. Perfect. So we need to import multiply sinus absolute, and finally we need to convert this one into a scale transformation. So we have our third transformation, which is scale equals divide of perspective by a subtraction of perspective and translate Z. So I need to import divide and sub. Let's have a look. So here I'm having something strange, and it's because I'm using degrees here instead of radian. So I think 90 degrees is mat pi divided by 2. Let's try. Okay, and here, of course, it's not degrees anymore, it's radian. So let's have a look. Yes, so now this looks more like what we are trying to achieve. And so I think the last step, I mean, maybe one thing we can add to add some more realism is to add some shadow animation. So here we can get actually quite complex we can do something quite complex to try to imitate the shadow that each view has on top of each other. But here we're gonna do something very simple with a black view and some opacity, but we could use like some linear gradient instead. Let's do something quick. So style sheet, absolute fill object, background color black. Oh, I guess that didn't work. Okay, here it is, and then we can just add some opacity. So, which we're going to interpolate in the scale value, opacity, interpolate, scale, input range goes from 0 to 2, output range, let's say, I don't know, 0, 7, 1. Oh no, sorry. 0, 7 to 0. Yeah, so here we have like some shadow effect, which I think is quite good. So last step, we need to interpolate the background color, where is it? Where is the background color? So we have background color red here, which we're gonna receive as a property. And it's going to be an animated value because it depends on animated values. And so we pass it as parameter here as well. Now, I guess I can pass it as parameter here. So I have an helper function, which I copied and pasted from the reanimated example directory, which is called interpolate colors. And we're actually going to use basically the same thing we used to interpolate the color statically, right? We used color interpolate to statically interpolate the colors. Here we do it using reanimated, so we go from 0 to 1, and the animation value that we need to interpolate over, we just need to look, where is it? So step palette is step by key. So we need to do multiply, step by index. Sorry about that. Let's have a look. All right. Yeah, I think it's pretty good. Alright guys, I hope you enjoyed this video. The Clear app is full of great animations and effects, so it's definitely an app we're gonna look at again in the future. So I'm really looking forward to talk to you guys soon. And in the meantime, happy hacking.